Hi Calculus, welcome back. Our objective today is just going to be to set up related rates problem, and this is the last topic of the semester. Related rates problems are really how do derivatives kind of interact with one another, and you'll typically see these as everybody's favorite word problems, but we're going to take a whole day and just set these up like you will see them without the words. So I've basically taken the same problems and looked at just the setup of them, like the calculus of it, and taken all the words away, and then with the next lesson we will put the words in or back in, and if you will just bear with me and really pay attention to the setup, it's going to make the word problems really very doable. Alright, so I've got the checklist on the screen, you know what to do from here. Alright, will you please write in your notes d dx y squared? So d dx is a verb. This means take the derivative with respect to x of y squared. Okay, if you have dy dx, that's a noun. This is the derivative of y with respect to x. Okay, so notice that your variables don't match. So here I would have 2y times dy dx, or if I had f of x squared, my derivative would be 2f of x times f prime, right? Same thing, I'm just using y instead of f. Okay, now will you write this, please? d dt, so the derivative with respect to t of x squared. I'm going to force pause on your screen, see if you can figure this one out on your own. So for this one we would have 2x, that's the derivative of the outer, times dx dt, that's technically the derivative of the inner, because we're assuming x to be a function of t, which will usually be time, right? Okay, let me drag my little guy down. Okay, so we are going to do a setup only. So we have been differentiating with respect to x. Now we're going to differentiate with respect to time t. And we're assuming that both x and y are functions of time. Okay, so I'm going to force pause on your screen. Go ahead and copy the equation for me. Alright, so if I'm differentiating the left side, do I have any special rules? No, we just need to keep in mind that we're going to derive both sides with respect to t. Okay, so I'm going to put d dt, take the derivative with respect to t, and again notice none of the variables match. Okay, so I'm going to need to multiply by dx dt or dy dt anytime I derive. Alright, so I've got 2x, now dx dt, plus, now I need to differentiate y squared, which would be 2y, now dy dt. Okay, so that's the left. Now, any special rules on the right-hand side? Now, on the right side, I need product, right? So x times y. Let's see here. Okay, so I'm going to derive the first, but again with respect to x, t. So it'll be 1 dx dt, right? Now I need to hold the second, so I'm just holding y. Then plus for product. Now I'm going to reverse it. So hold x, hold the first. Now derive y with respect to t, so that'll be dy dt. And I'm just going to stop there for now. Okay, I just want to do the setup only. Alright, and force a pause on your screen. Can you please copy everything I have for example 1? We're back. So we want to find dy dt when dx dt is 2, x is negative 1, and our equation is 4x squared plus 3y equals 2. So the first thing I want you to do is look at the equation given and decide how many variables you have. And there's 2, right? X and y, and both, we're assuming that both move with respect to time, okay? So what I'm going to do is make a table, or a chart, however you want to think about it. And you want to do one row for x and one row for y, okay? So what we're going to do is we're going to put x equals and y equals on the left, and then on the right we're going to put their respective derivatives with respect to time, okay? Again, just making a table for both variables and then both derivatives with respect to time. Okay, so let's go ahead and fill in what we have. We know that dx dt is 2, so I'm going to put that here. And I know that x is negative 1, so I'm going to put that here. And then what am I looking for? This is important. I'm looking for dy dt, so I want you to put a question mark there. Now I don't know y, Could I find it though? Yeah, I could plug in -1 for x and solve for y, right? If I need it, I'll go back and do that, but I don't want to do more work if I don't need it, okay? But do keep that in mind. If we do need it, we have that tool available to us. Okay, so let's go ahead and derive both sides with respect to t, because I want to find dy dt, right? Okay, so any special rules on the left-hand side? No special rules, so I have 8x dx dt plus 3, do I need a dy dt? I do indeed, right? The variables don't match. Equals, now what's the derivative of 2? Just 0. All right, okay, now let's go plug in what we have. So I've got 8. Now x coming back from our chart was -1. dx dt, according to our chart, was 2. Then I've got plus 3. dy dt is what I'm looking for, right? And then equals 0. Okay, so notice I didn't need y, all right? So that was good news for us. So let's keep going here. 8 times -1 times 2 is -16. I'm going to go ahead and bring that over to the right-hand side, so that's positive 16 there. So I've got 3 dy dt is 16. In other words, dy dt is 16 over 3, and that's our final answer. All right, force a pause on your screen. Go ahead and copy example 2 for me. So once again, we've got two variables, right, y and x. I'm assuming they both vary with respect to time. So I'm going to make a chart, 2 rows, 2 columns, and we are going to, let's see here, have x in, x here, y here, and then their derivatives on the right-hand side. Really important that you make this chart every time, okay? I want to see this in your assignment. All right, and we want to find dx dt, right? So I'm going to put dx dt is what we're looking for. So I'm going to put a question mark there. Again, that's important, so you know that you don't need to fill that in. That's what I'm looking for. And dy dt is -2. And x is 1. Okay, and we don't know, again, what y is. If we need it, though, I can plug 1 in for x into the original equation, right? Okie doke, so we want to take the derivative of both sides with respect to t. Any special rules on the left side? No special rules on the left. What about the right? Now, kind of two things, right? I need to rewrite, so this is going to be 2 minus x squared quantity to the 1/2, yeah? And then we are going to also need chain rule there, okay? So let's bring this down here. All right, so let's go ahead and derive both sides with respect to t. So I've got 3y squared. Do I need a dy dt? Yes, I do. Equals, okay, now I need some chain rule, okay? So I'm going to bring that 1/2 forward, and then I've got quantity. Okay, 2 minus x squared, hold that, right? Drop your power, -1/2. Here's the derivative of the outer, times the derivative of the inner, don't lose this negative, so -2x. And then I've got one more inner function, because x is its own function as well, so I need to take the derivative of x with respect to time, okay? All right. So now I can plug in. Do notice I do need what y is, right? So how can I do that? Well, again, I can plug in 1 for x into the original there. So when x is 1, I get y cubed. Let's do it up here. I get y cubed equals square root of 2 minus 1. So y cubed equals square root of 1, which is 1. So y must be 1, right? Okay, now we can go ahead and plug in. I'll let you plug in and go ahead and solve for dx dt. and then you can check your answer with mine. I'm getting dx dt is 6. A couple of things to notice. You had a factor of 1/2 and 2, so if you want you could cancel those out to make your arithmetic a little bit easier. Just don't lose this negative here. The stuff in parentheses ends up being 1, right? And 1 to any power is 1, so basically that goes away. So you end up just getting negative 1 dx dt on the right-hand side, negative 6 on the left-hand side, which gives us 6 as our final answer. All right, you all, that is all we have for today, and I will see you next time.